giving us force space-time. We were already looking into geodesics and a different way of doing the math because the usual way, Euclidean way of doing math doesn't work anymore in general theory of relativity. So remember, if you go to the lives where we talked about the math for GR, you basically have to, like, we define the metric, geodesic, the way for, like, the way of doing math, which will set things up so that we can write down the equations in general theory of relativity. Remember, like the Einstein tensor and the Ricci tensor, remember all that stuff. That is the mathematics that was, we had to set that up in order to do general theory of relativity. So you already have to do, you're already in a different realm. If you can do 4 space-time, why not 11 space-time, right? If you're already in a different realm, why not build on that? So basically, string theorists were like, well, we have to start with GR. We have to at least do the math in a way which allows and accepts and encompasses general theory of relativity. Like there's no 2 ways about that. You have to start there. It's something that has to build on that, right? On top of that. So, I think one of the greatest gifts of superstring theory, if you ask me, not a string theorist, I'm not a string theorist, simply just discussing the topic. The biggest thing about string theory is that these people who work on it are very good at GR. They're good at relativity. So those are the professors whose class you want to take if you want to learn general relativity. Okay, so if there's one takeaway from this discussion is that those people can know the math for GR, and not everyone can do the GR math. So you know who to ask for that, okay? So superstring theory can also encompass all of Einstein's work on relativity. As the string moves in space-time, it forces the surrounding space around it to curve, precisely as Einstein had predicted back in 1915. In fact, superstring theory is inconsistent unless it can move in a space-time consistent with general relativity. It builds on general relativity, so of course it should work, As physicist Edward Witten has said, even if Einstein had never discovered the theory of general relativity, it might have been rediscovered via the string theory. Sure. Witten says string theory is extremely attractive because gravity is forced upon us. All known consistent string theories include gravity. So while gravity is impossible in quantum field theory as we've known it, it's obligatory in string theory. However, string theory makes some other quite surprising predictions. Strings can only consistently move in 10 dimensions, 1 dimension of time and 9. So maybe I was wrong. I don't know where I got the 11 dimensions. String theory makes some other quite surprising predictions. Strings can only consistently move in 10 dimensions, 1 dimension of time and 9 dimensions of space. In fact, string theory is the only theory which fixes the dimensionality of its own space-time. Like the Kaluza-Klein theory of 1921, it can unify gravity with electromagnetism by assuming that higher dimensions can vibrate, creating forces that can spread throughout 3 dimensions like light. If we add an 11th dimension, oh, this is where I got it. The M theory, that has 11 dimensions. If we add an 11th dimension, then string theory allows for the possibility of membranes vibrating in hyperspace. This is called M theory. So I thought it was 11 dimensions because the M theory has 11 dimensions. Apparently, string theory just has 10, including time. What time is it? No, I'm not a string theorist. Like the Kaluza-Klein theory of 1921, it can unify gravity with electromagnetism by assuming that higher dimensions can vibrate, creating forces that can spread throughout 3 dimensions like light. If we add an 11th dimension, then string theory allows for the